my name is Dietz and I'm in 11th grade.
Hi, my name is Daniel Simoes and I'm also in 11th grade.
And today we will be presenting our project called Fingerprint Investigation. To give you some background information, when the fetus reaches 6 months, small grooves will form on the epidermis. Those small grooves or ridges are the baby's fingerprints. As the baby grows older, their fingerprint will not change. The fingerprint will stay the same from when they were a fetus all the way through adulthood. As they grow, the size of the fingerprint will grow, but the pattern will not change. There are 3 different pattern types of fingerprints: the loop, the whorl, and the arch. Each person is born with a unique fingerprint, but they will fall under one of the patterns above. Since everyone is born with a unique fingerprint, fingerprints can be used for identification. Children inherit their parents' DNA, and although they do not inherit the same exact fingerprint, do they inherit the same type of pattern?
Now moving on to the abstract. Often you may look at 2 boys and wonder if they are related because they look so similar. The same goes for a mother and her daughter. A lot of the time, it is easier to tell that 2 people are related based off of their physical traits. When a child is born, they receive half of their mother's DNA and half of their father's DNA, which explains the similar physical characteristics. In life, fingerprints are extremely important for identification because each person has their own unique fingerprint. Knowing this, can we find similarities between related and unrelated fingerprints?
The hypothesis we came up with for our project is if 2 fingerprints show many similarities, then they must be family members because DNA is passed down from parents to children, and some of the DNA inherited has an influence on the type of fingerprint the child has.
The materials necessary for this project are as following: paper towels, moist paper towels, white printer paper, parchment paper, pencil, clear tape, scissors, related pairs of people, and unrelated pairs of people.
To allow this experiment to run smoothly, first, make sure the participant is willing to give their fingerprint, as these can be used for identification. Have the participant sign their consent. Second, rub a pencil on a piece of parchment paper. Make sure it is completely dark gray. Third, use a moist paper towel to clean the person's right thumb. Fourth, thoroughly dry the person's thumb with a dry paper towel. Fifth, press and rub the thumb onto the space of the graphite. Sixth, roll the fingertip onto the sticky side of a clear piece of tape. Seventh, cut off the section of tape containing the fingerprint and stick it onto a piece of paper. Eighth, perfect your technique of steps 2 through 7 before starting a usable trial. Ninth, and the final step, when your technique is perfected, repeat steps 2 through 7 with multiple pairs of both related and unrelated participants. With each participant, assign a letter and number to distinguish each participant. Related pairs will be the same number.
As you can see in the picture, these were just some of the pairs of fingerprints that we have tested. These were pairs 1, 2, 3, and 4. The pairs with letters X and Y represent unrelated pairs, and the A's and B's represent related pairs. We could then categorize each of these as a loop, arch, or whorl, but this was much better to do in person, and the picture is not easy to distinguish each.
After taking fingerprints, you will want to analyze them. So first, you will classify each fingerprint as a loop, arch, or whorl pattern. Second, you will want to calculate the percentage match between related and unrelated pairs. Third, you will want to create a pie chart. Fourth, compare the percentages of related and unrelated pairs and interpret what this comparison means.
As discussed in the previous slide, we used our data to create pie charts and percentages. Here are our results. 100% of related pairs shared fingerprint patterns, but only about 1/3 of the unrelated pairs shared fingerprint patterns. And this makes sense because there are 3 different fingerprint patterns that one can have.
After After our fingerprint investigation, we can conclude that although not every child matched both of their parents' fingerprints, they matched at least one. Siblings match fingerprints every time. It can be concluded that fingerprints are inherited from at least one parent, which means that the child has the same pattern as one of their parents.
Here are the resources we used throughout our investigation. We thank you for listening to this presentation and hope you learned something.